So today our lecture topic is incidence matrix, and which is a part of the graph theory. So this is the title, incidence matrix. So basically incident matrix is a matrix which represent the edge and the vertex relations of a graph, and it is defined in this way that let G be a graph and G be a graph, and with suppose n vertices and suppose e number of edges, and also no self loop is considered. So no self loop. So parallel edges may consider, but there is no self loop. Then we define an n cross e matrix, and n cross e means number of rows equal to the number of vertices, and this number of columns, this is equal to the number of edges. So that's why we set the vertex in row wise and we set the edges in column wise to make that incident matrix. So this is n cross e matrix M, and suppose this M is denoted by Eij and n cross E, and where this Eij is defined in this way that this value of Eij, this value will be 1 if, so one more thing, so we are actually defining this incident matrix now for a connected and also not only a connected graph but also a non-directed graph. So for a connected non-directed graph, so this is the definition. So let G be a graph and where n vertex and e edges and number of self loops. So this also holds for the disconnected graph, but the way is something different. So but the definitions will be same also in the connected graph. But for the non-directed graph, this is the definition, but for the directed graph you will get some different definitions. You will get not only one, also -1. So that's why the non-directed graph and for the directed graph these incident matrix are different. So here for the non-directed graph, Eij value will be 1. That means in your matrix the ith row and the jth column element will be 1 if the edge Ej is incident to the vertex Vi, and otherwise this value will be 0. So this is the definition of the incidence matrix for a non-directed graph. So let's take one example. So just to clarify the how to determine the incident matrix of a non-directed graph. So we are taking one example of a graph of a non-directed graph. So this is one example, and it is, suppose we are taking the vertex as this is V1, this is V2, this is V3, and suppose this is V4 and this is V5. Okay, so this is one isolated vertex and this is one pendant vertex of degree 1, and here for the other vertex here degree is 3, here also degree is 3, here degree is 2. Now we are giving the edges. So this is E1, suppose this is E2, and this value is suppose E3, and this is E4, and this is E5. Now to determine the incident matrix of this graph, so we are denoting suppose this by M. So and this is suppose the graph G. So incidence matrix of this of the graph G is nothing but is equal to M of G and is equal to, so just write this matrix in this way, that row wise you will take the vertices. So number of vertices V1, V2, V3, V4 and V5, and in the column you will take the edges E1, E2, E3, E4 and E5. So now just check the edge and the vertex relations. Now from the definition you can see that this element is actually a ijth element, this element. So this is a 1 1 element, this is a 1 2 element, this is a 1 3 element. Now a 1 1 element means if the, so this is the j position and this is the I position. So if the first edge, that means edges E1 is incident to the vertex V1. So if the edge E1 is incident to the vertex V1, then we put here 1. So obviously this E1 is incident to the vertex V1, so we are putting here 1. Now second is, if the it is A1 2, that means if the edge E2 is incident to the vertex V1. So E2 is also incident to the vertex V1, that means you can put here 1. So that's the way how you can draw this matrix from the definition, but instead of that we will actually do it in the column wise form, because you can see that here this E1 is attached with two vertex. So that's why whenever we take the E1, so E1 is incident to the vertex V1 and E was incident to the vertex V2. So we put 1 and 1 in place of V1 and V2 and we fill the other values with 0. After that comes to the E2. So this E2 is incident to the vertex V1 and V3. So just put in place of V1 and V3 1 1 and fill the other values with 0. Similarly, do it for the other vertex. So for the E3, it is incident to the vertex V2 and V4. So just put 1 in place of V2 and V4, and okay, not E3 is connected to the V2 and V3. So V2 this is 1, V3 this is 1 and the other values are 0. Also the E4 is one parallel edge, and in this E4 we will put the same values in the V2 1 and the V4 1 and the other as 0. And in the E5 you can see that we will put here the 0, because E5 is connected with V3 and V4. So just put here 1 in place of V3 and in place of V4 and put every other values with 0. So here you can see that there are total 5 number of edges and also 5 number of vertices. So that's why this is a 5 cross 5 matrix, and this is called the incident matrix of the graph G. Okay. So I think now it is clear to everyone that what is the incident matrix for a connected non-directed graph. So now we have some observations directly from this matrix. Now just if you closely observe this matrix, that you can see that since every edge is incident to two vertices, so that's why in every column you will get exactly two number of ones. So here you can see there are exactly two number of ones, here also exactly two number of ones, here also two, and here also two, and here also two. So by using that you can also verify your incident matrix, that if you get more than two number of one in a column, then it will be wrong. So in every column there will be exactly two number of ones. This is the first observation. And the second observation, so just we are writing the first observation. So number one, so observation one, so the observation one, this is that every each column of M has exactly two ones, two ones. Okay, take this as this two ones. Okay, and then one more thing, observation two, if you see it in the row wise, then you can see that the total number of ones in a row actually represent the degree of this vertex. So if you see the v1, so there are two ones, so that means degree of v1 is 2. Here the degree of v2 is 1, another one, and another one, so there are three number of ones, so that means degree of v2 is 3. So from this number of ones you can, here for the v3 1 2 3 and 4, so for the v3 total number of 1 is 4, and for the v4 the degree is 1, it is a pendant vertex. For the v5 you can see that there is no edges, so degree of v5 is a 0, it is isolated vertex. So that means the number of ones, number of ones, and in each row, in not in each row is equal to the degree of the corresponding vertex, to the degree of the corresponding vertex. Okay. Like here we can note that from this line that degree of v1 is 112. From here degree of v2, this is equal to 1 2 and 3, and degree of v3, this is equal to 4, degree of v4 is equal to 1, and degree of v5, this is equal to 0. This is one of the isolated vertex. And one more observation, so corresponding to a isolated vertex you will get entire 0 row. So since v5 is an isolated vertex, so corresponding to v5 the whole this entire row is 0. So whenever some this type of isolated vertex occur, then you will get this type of 0 rows corresponding to that. Okay, so that means this is number 3. So in the third observation we see that a row with all zeros and represents an isolated vertex, okay. Number 4, now we actually comes to the parallel edges. So here also you can see that E3 and E4 are parallel edges, these two edges are parallel edges, and corresponding to this E3 and corresponding to this E4 actually will get the identical columns. So these two columns are exactly identical. So corresponding to parallel edges in a graph, you will get some identical columns in your matrix. So parallel edges, this is another observation, that parallel edges in a graph will produce identical columns in the incident matrix, in the incidence matrix. So these are some observations and basically important observations from this incident matrix. So from this incident matrix you can determine at least some of the properties of the graph by using this. So this is for the connected graph. Now the problem is if your graph is disconnected. So before going to the disconnected graph, we will discuss another graph, and just minutes. So we are taking another graph for the considerations. Like this is another example of graph. Suppose this is the figure of the graph, and just draw here. This is one, another. So take this as V1, this as V2, V3, this as V4, and this as V5, and here it is E1, E2, it is E3, E4, it is E5, and E6, and E7. So total 5 number of vertices are there and 7 number of edges are there. So it will be a 5 cross 7 matrix, incident matrix. So here if this graph is represented by this some G prime, suppose this graph is represented by G prime, then the incidence matrix that M of G prime, this is nothing but, so just make one again of such matrix. Within the column it is E1, E2, E3, E4, E5, E6, and E7, and here you will get V1, V2, V3, V4, and V5. Now fill the boxes. So here we start with the edge E1. So this edge E1 is incident to V1 and V2. So put 1 in place of V1 and V2, 1, and after that fill the other values with 0. E2 is connected with V2 and V3. E2 is connected to V2 and V3. So place 1 in place of V2 and V3 and fill every other values with 0. E3 is connected with V1 and V3, so put in place of V1 and V3, these are 0 and other places 0. Now E4 is connected with V1 and V4, so put 1 and 1 in place of V1 and V4 and every values with 0. E5 is connected with V3 and V4, so place E3 means this is 1 and V3. So E5 that means V3 and V4 and every other values are 0. Then E6 is connected with V3 and V5. E6 is connected with V3 and V5 and every other values is 0. And then E7 is connected with V3 and V4. E7 is connected with V3 and V4, then every other values are 0. So here E5 and E7 are actually parallel edges. So that's why the columns corresponding to E5 and E7 will be identical, and you can easily see that these two actually columns are identical columns. So if you closely see that this column and this column, these both columns are actually identical column because these two are parallel edges. So now this is the incident matrix, and this is one of the 5 cross 7 incident matrix and corresponding to that. Okay, so this is the process of actually drawing the incident matrix from the graph if the graph is given, and this is for the connected graph. Now we comes to the disconnected graph. So if your graph is disconnected, so for disconnected graph, so what is disconnected graph? So disconnected graph means you can for any for some of the a pair of vertices, you will not find any work. That means, suppose this is a graph, this is one of the graph, and where you can see, if we take this as v1, this as v2, this as v3, this as suppose v4, and this as suppose v5 and it is v6, then you can see that from starting from any one vertex you can reach every other vertex by using some walk. That means there exists at least one walk by which you can go from one vertex to any other vertex. But if we draw this graph like this way, that means this is another, suppose v7 and v8, then you can see that you can't go from the v1 to v7, or you can go from the v4 to v8 or v3 to v7. So that means you can go from any one vertex from this part, uh, that from this part and to the portion of that part. Okay, so it is not possible to go from this portion of the graph to that portion of the graph. So that's why this is one of the example of disconnected graph. And this connected portion, this connected subgraph of the disconnected graph, graph are called, subgraphs are called component. So if this total graph is G, then these two graph, this is suppose G1 and this is suppose G2, then we can see that G1 and G2 are connected component of G. So that means if a graph is disconnected, then you will get some of the connected component of G. Now, what is the way for the disconnected graph and what is the definition? So, for two components of a disconnected graph G, of a disconnected graph G, uh, suppose there are okay, not for, suppose there are two components. So let there are two components of the disconnected graph G, and which are G1 and G2, then the width after that. So let there are two components of the disconnected graph G, and which are G1 and G2, and also let AG1, M of G1 and M of G2 be the incident matrix of those components. Since the components are connected, so you can easily find the incident matrix of those components. So after that, the incident matrix of G, the incidence matrix of G, the original graph G is Mg, and which looks like, just place these two matrix diagonally. So this is Mg1, so this first matrix is M of G1, and place the Mg2 matrix diagonally and place here 0 and 0, and this matrix is the incident matrix. So here the order of the zeros may be different. These are not same zero, but these zero are the null matrix. So this is the pattern of finding the incident matrix of G. So there may be more than two components, not necessarily two components that in a disconnected graph. So if you get more than two, suppose three, then you have to place these three matrix diagonal by diagonal, and after that just fill every other entries with zero. So if there are four, then place the four incident matrix of the components diagonally and fill the other values with zero. So that's the process for finding the incident matrix for the disconnected graph. Okay, so just let's take one problem for the disconnected graph, and suppose this is one of the example of the disconnected graph. So draw, so construct the incident matrix. So this is the problem. Construct the incidence matrix, incidence matrix and of the following graph, of the following graph. So this is the graph, suppose, and here this is V1, this is V2, this is V3, and this is V4, and suppose this is V5 and V6, V5, V6 and V7. Okay. And this is E1, this is E2, this is E3, E4, E5 and E6. So here you can easily see that this is one of the example of the disconnected graph, because this is G1, one connected component, and this is G2, another connected component of the whole graph. So let G be that graph. So G be the whole graph, and in which you can see that these two are the connected component of this G1 and G2. Now you can easily calculate the incident matrix for the G1 and for the G2. So let the incident matrix of G1 be mg1. So after, so this is the mg1, and m of G2, the incident matrix for the G2, and this will be again another matrix. So in the mg1, actually we will put the edges in the column wise. So it is E1, E2, E3 and E4, and vertically we will put again V1, V2, V3 and V4. So here we will put the E5 and E6 only, because there are only two columns, and in the row wise we will put V5, V6 and V7. After that just fill the every other values. So what is the value of the E1? So E1 connected with V1 and V2, so put here 1, put here 1, and every other value is 0. E2 connected with V2 and V3, so here 1 and here 1, and every other 0. E3 connected with V1 and V3, and others two values 0. E4 connected with V3 and V4, connected with V3 and V4, and other values 0. Here also for the G2, you will get E5 connected with V5 and V6, and this is 0. E6 connected with V6 and V7, and this is 0. So that's the matrix for mg1 and mg2. Now the incident matrix for the graph G. Now the incidence matrix for the graph G, for the graph G is mg, and this mg is the matrix which created by placing these two matrix diagonally. That means it is 1 0 1 0, then 1 1 0 0, then 0 1 1 1 0 0 0 1. So this is the end of the one diagonal one matrix, and just after that place another matrix from the end of this diagonal matrix, end of this matrix, and this is 1 0 1 1 0 1. So that is the second matrix. So after putting these two matrix, you can see there are total number of vertices is 7. So there will be 7 number of rows and total the number of column is 6, 4 here 2, so it is a 7 cross 6 matrix. And you don't need these two separated line or the separator line. We just draw it to so that you can understood it better, but you don't need these two separator line. So now just fill the other values to complete the matrix, and these are by 0. So here will be some 0 0 0 0, and here also 4 0, and here also 0 6. And this matrix is the incident matrix for the graph G. So now you can see that in this way you can draw incident matrix for the graph G. So but not necessarily you have to do it like this way, that every time first calculate this G1 and G2 matrix separately, and after that put this two matrix in one matrix. So you can directly also draw this matrix in this way. So suppose in your graph your problem is now the matrix graph G is, if the graph G is in this way, that suppose we are again taking the previous type of matrix. So here you can see that this is one of the matrix, and where we are taking the another part as this is another disconnected path. So here this is V1 suppose, and this is V2. Take it as V3, it as V4, and it as V5, and it is as V6, V7, and it is supposed as V8. And after that just fill the every other edges with this is E1, E2, this is E3, it is E4, it is E5, and it is suppose E6, it is E7, it is E8, and it is suppose E9. So this is another graph, and where you can see that total 9 number of edges are there, and total 8 number of vertices are there. So it is a large matrix, it will be a 8 cross 9 matrix. So now let's start drawing the matrix, but this time we will draw it directly in one graph, so not by taking multiple number of graph, multiple number of matrix. So just start it. So first of all, what do we do? So we draw a large matrix, so that's why we are taking a large third bracket here, and then we fill the total part. So it is E1, E2, E3, E4, E5, E6, E7, E8, and E9. So total 9 number of edges, and V1, V2, V3, V4, V5, V6, V7, and V8, total 8 number of vertices. After that, the first graph, the first component G1, this is the first component, and this first component G1 actually contains the 5 number of vertex and 6 number of edges. So just we are drawing the separator lines so that we can understood it better. So just draw it. So 5 number of vertex, so there are total 5 number of vertex and total 6 number of edges. So our first matrix contains in this figure, and the second will contain in here. So we have to determine these two matrices. So for the first we will fill that box, and for the second we will fill that box, and we will place zeros in every of these two blank places. So just start with the first portion. So at the starting, the E1 is connected with what? V1 and V3. So place here 1 and 1 and fill the other values with 0. Then where is E2? Because it is in E2. So E2 is V1 and V2. So V1 and V2 and place other values with 0. Then E3 is again V1 and V2. This is parallel edges. So that's why we get identical columns. And E4 is connected with V1 and V4. So V1 and V4, and these values are 0. E5 is connected with V3 and V2. So V2 and V3, and these values are 0. E6 is connected with V4 and V5, V4 and V5, and the other values are 0. After that, complete this part. So for the second component, this portion, if you do the same thing, so your E7 is connected with V6 and V7, so place here 1 and 1 and this value is 0. E7, then E8 is connected with V6 and V8, so put here 1, put here 1 and they are 0, and E9 is V7 and V8, so V7 and V8 and put here 0. So that is the complete of two of this incident matrix. So after that, fill the every other remaining values with 0, 0, 0, here also 0, 0, 0, and here also 0, 0, all values with zeros. Just fill it by the zeros and you will get your incidence matrix. Okay. And this is one of the 8 cross 9 incidence matrix. Okay. So this is the process of drawing the incident matrix and for a disconnected graph. And obviously these are all non-directed graph, not directed graph. We'll come to the directed graph later. So sometimes also you may get some problems. So where the incidence matrix is actually given and you have to find the graph from the incident matrix. That means from the relation of the matrix you have to draw the graph. So now let's take one of this type of problem, that where the matrix is given and you have to find the graph. So this type of question you may see that draw the graph. So draw the graph and corresponding to the following incident matrix, corresponding to the following incidence matrix, Suppose your incident matrix is given as 1 0, so take it as 1 1 0 0 0. Then okay, just 1 minute, we are taking it lengthier, 0 0 0, and then 0 1 1 0 0, then 1 0 0 1 0 1 0 0, and then 0 0 0 1 1. Suppose this is the incident matrix. Now we have to draw the graph from this incident matrix. Now easily you can see that there are total 4 number of columns, so number of edges is 4, and there are 5 number of rows, so number of vertices are 5. So just mark this vertices and the edges first. So this is V1, so it is not given in your question, so we are now marking it. So it is V1, it is V2, it is suppose V3, it is V4, and it is suppose V5. After that, mark the edges E1, E2, E3, and E4. Okay. Now we will pick the relation and between them to draw the graph. So first of all, your E1 edge is in between V1 and V2. So just draw the V1 and V2 here. So draw the E1 edge and it is between what? V1 and V2. Okay. Now the E2 edge, you can see that E2 edge is a connection between V2 and V3. So V2 is the common vertex. So we start with V2 and we draw it in this way. So in between V2 and V3 there is an edge and it is E2. Now see, the E3 connects the V1 and V3. So E3 connects the V1 and V3, so just join these two. So E3 connects the V1 and V3. After that, E4 connects the V4 and V5. So we don't have V4 or V5 here. So that means it is like one of the disconnected graph. So we are drawing one V4 and V5 here. So suppose this is V4 and V5, V4 and V5. Okay. So this is the graph because this V4, V5 have no connection from the previous graph. So that's why this is also a disconnected graph. Now you can visualize the separator lines here. So what is the separation? So this is the separation line and you can see that all their values are 0 and here all values are 0. So this is the matrix for the V4 V5 portion, this component portion, and this is the matrix for this component portion, that with the vertices V1 V2 and V3. So that is the way of drawing the graph corresponding to the incident matrix. So if the incident matrix is given, and then you can draw your uh, graph from the matrix. Okay, so now take one other problem, and suppose as your homework, and after that we will go to the directed graph. So before that, just take one problem. So just as a homework, take it. So some of the homework from the some homework, and from the non-directed graph incident matrix, incidence matrix. So from the non-directed graph incidence matrix, just take some of the problems. Now just 1 minute, I'm giving some problems. So this is the first problem. Take it. Number 1. So draw the incident matrix. Draw the incident matrix of the following graph, of the following graphs. Number 1. So first, this is the graph. So take this as an graph, and here just take one line and another vertex isolated here. So this is V1, this is V2, V3, V4, and suppose this is V5 and it is V6, and take the edges as this is E1, E2, E3, this is E4, this is E5, E6, and this is E7. And just draw the incident matrix of this graph. Number 2, take another graph to draw the incident matrix, and this time this is one of the disconnected graph. Just take it like this, that, draw it here, and take also one here, and another thing disconnecting these two graph. These are 2 points. Okay, and here also another graph, other points. So this is V1, V2, V3, V4, V5, V6. This is the V1, V2, V3, V4, V5, and V6. And here another graph. This is V7, this is V8, and this is V9. This is another component actually, and their connecting lines are E1, E2, E3. Here it is E4, it is E5, it is E6, it is E7, E8, E9, and it is E10. Okay, so these are the edges of the disconnected graph. Now just draw the incident matrix of these two graphs. Okay, and now also draw the graph, some problems, another types of problem, which is draw the graph from the incidence matrix. What is the problem? Problem is number 1. This is the first matrix. This is 1 1 0 1 0 1 1 0, then 0 0 1 1, then 0 1 0 1, and then this is 1 0 0 1. 1 0 0 1. So this is the matrix, and from where just you have to calculate the incidence matrix. Okay, this is the incident matrix actually, from where you have to calculate the graph. And similarly, if I give you uh, another problem, so number 2, just take another problem, so where the total number of vertices are low, and this is suppose 1 2 3 4 5 6, and this is 1 0 0 1 0 0, this is 0 1 1 0 0 0 0 0 1 1 0 and 0 and 0 1 0 0 1 0. This is another matrix. This is 1 2 3 4 5 6 cross 4 matrix. So 6 number of vertices and 4 number of edges are there, and here total 4 cross 5, so 4 number of vertices and 5 number of edges are there. So just draw the graph of the incident matrix. So for the first two problem, these all are non-directed graph. So first draw from the incident matrix, and then from the incident matrix draw the graph. Right? So now we comes to another topic, and which is another important topic, not the topic part actually. So this is for the directed graph. For the directed graph, that means for the diagram. So a diagram means a graph, and where the every edges have some direction, particular direction, and there is some basic difference here in the directed graph and the non-directed graph. That means suppose this is one edge in the non-directed graph, and this is suppose v1 and this is v2, and this is one non e1 in between the these two vertices, or incident to these two vertices. In that case, we say that this u1 is represented by either of v1 and v2 or of v2 and v1. You can place both instead of u1. So u1 is represented by both v1 comma v2 and also v2 comma v1. That means u1 is both incident to the v1 and v2. But whenever it is the directed graph, so here you will get some directions, particular directions. It either it is from v1 to v2 or it is from v2 to v1, and this is also the same edge, and suppose this is e1. So here e1 is actually the v1 comma v2, but you can't say but that it is v2 comma v1. So if you take that, it will be wrong. So here in the directed graph, u1 is always represented by v1 comma v2, but not the v2 comma v1. But there is not no this type of restriction in the non-directed graph. So that's why it is very much important. So this is the distinction between the directed and the non-directed graph. That means here u1 direction, if it is from v1 to v2, then we can say that there is an edge from v2 to v1. So there is no edge from v2 to v1, but there is an edge from v1 to v2. Okay. So now we comes to the directed graph concept, that how we can actually draw the incident matrix for the directed graph. So here a simple difference is there. So we will put 1 if the u1 edge is directed out from one vertex, and if it is in, then we place -1 here. So just take the definition of the graph. So first we state it for the connected graph. So for the connected graph first, and for the disconnected graph, like the same thing, that we will do it for the different connected components, and after that we assemble them to form the for the disconnected graph. So for the directed graph, here the concept is E1 is incident out from the vertex V1 and E2 is incident in to the vertex V2. So out from the V1 and into the V2. Now the definition is, so for a graph G, with n vertices and E edges, the incidence matrix M of G, which is again the same as Aij, where Aij is a n cross E matrix, is defined as Aij, this value will be 1 if the jth edge is that means jth edge means the Ej is incident out from the vertex Vi. So if it is incident out, then it will get 1 and minus 1 if the jth edge Ej is incident in to the vertex Vi and 0 otherwise. So that means in the previous incident matrix both have got 1 and 1, but here the vertex with the outside direction will get 1 and with the inside direction will get minus 1. So if the E1 is incident out from the vertex V1, then it will get 1. If the E1 is incident to the vertex V2, then this 1 2 element will get minus 1. So that is the pattern. So corresponding to E1, so one will get 1, another will get minus 1 here. So now take one problem to understood the process. So here the difference is the vertex from where the edge is actually coming outside will get 1 and from where and to where it is actually going in, so it will get minus 1. So now take one simple problem. So just take it. Find the incidence matrix of the directed graph or the directed graph, and this is the graph suppose, and we are giving some directions here. So suppose this is the direction in each edge, and actually directed graph means each of the edges have some direction. You can actually left any one edge without direction. So for the non-directed graph, there is no graph, no edges with direction, and for the directed graph, there is no edges without direction. So you can mix and match these two types of graph. So that means this is V1, this is V2, this is V3, this is V4 and V5, and edges are this is E1, this is E2, E3, this is E4, it is E5 and it is E6. Okay. So now see here there are some directions given in the incident matrix. So first of all we do this in the same way. So incidence matrix M of G. So if this is actually G graph, then mg is equal to do the same process. So first write down the edges E1, E2, E3, E4, E5, E6 column wise, and V1, V2, V3, V4, V5 row wise. After that, close this matrix and now start filling the values. So first comes to the E1. So E1 outwards from the V1 and inward in the point vertex V2. So V1 will get 1 because E1 is incident out from the vertex V1 and incident into the vertex V2. So it will get -1 and all other values are 0. Similarly, E2 inside out from V2. So V2 will get 1, inside into the vertex V3, V3 will get -1. Every other value is 0. E3 inside out from V3, so V3 will get 1 and inside into the vertex V1, so V1 will get -1. E4 out from the vertex V1, it will be 1 and it is actually going to the V4 and it will, so E4 actually going to the V4, so V4 will get -1, every other value is 0. Similarly, E5 outwards from the V4, so V4 will get 1 and actually it going inside to the point V3, so V3 will get -1. E6, it is incident out from V4, so V4 will get 1 and V5 will get -1 and every other value is 0. So this is just the incident matrix of the directed graph. So in the directed graph, you will get 1 and -1. And if you just observe this graph, you can also see that the total number of -1 in a graph, -1 in a row is actually represent the in degree of this vertex and it is the out degree of the vertex, number of 1. So total number of 1 in a row represent the out degree of the vertex, and total number of minus 1 in a row represent the in degree of the vertex, respectively. Okay, so obviously respectively, that means respective vertex. So if you take the vertex V2, then you can see that there is one number of -1, one number of 1. So in degree is 1 and out degree is 1. So if we say the in degree and the out degree chart here, so this is in degree and the out degree chart. So you can see that the in degree of the V1 is -1, one number of -1, in degree is 1 and out degree is 2. Here in degree is 1 and out degree is 1, and here in degree is 1 1 2 and out degree is 1, and here in degree is 1 and out degree is 2, and here in degree is 1 and no out degree, so out degree is 0. So this is the total in degree and out degree, and the sum of the in degree and out degree is the degree of the graph, and you will know that the degree of the vertex actually. So these are the chart for the this is the matrix for the diagram, and for the diagram you can observe this type of properties also. Now one more thing, for the disconnected graph with the component G1 and G2, for the disconnected digraph with connected components graph G with the connected components G1 and G2, incident matrix, dense matrix, M of G is equal to, like the same, M of G1 M of G2 and 0 and 0, where this MG1, M of G1, this is G1, and M of G2 are the corresponding incidence matrix of the components of the components. Okay, so these are the, for the disconnected digraph also the concept is same, that first draw the graph and after that you can uh, similarly calculate the incident matrix for the directed graph also, disconnected type of directed graph. So just take one problem from the disconnected type of digraph. So find the incident matrix. This is the problem. Find the incidence matrix for the digraph G, and given as follows. And the matrix is, suppose this is the matrix, and suppose it is like this: 1 2 3 4 5 4 9. So this is V1, V2, V3, V4, V5, V6, V7, V8, V9, and here there are some directions also there. Just put the direction here. Okay. And then marking the edges as this is E1, E2, E3, E4, E5, E6, E7, and this is suppose E8, E9, and this is suppose E10. This edge is E10. That means this edge actually E10. 10 number of edges and total 9 number of vertices. So it will be a large matrix. So just start with the columns and the edges, columns and the rows. Okay, just put it here and then write down the values. So this is E1, E2, E3, E4, E5, E6, E7, E8, E9, E10. V1, V2, V3, V4, V5, V6, V7, V8, V9. So from in the E5, so it will be, so we are taking one division from V1 to V5 and E7. So V1 to V5 and E7 we are taking one, and from the others, the rest of the other we are taking that. After that we will start filling that. So U1 connects V1 and V2, it is outside from V1. So V1 will get 1 and V2 will get -1 and every other value is 0. For the E2, it is outside from the V2. V2 will get 1 and V4 will get -1 and other values are 0. E3 from V4, V4 will get 1 and V1 will get -1, other value is 0. E4 from V1, so V1 will get 1 and 2 V3, V3 will get -1 and every other value is 0. So from get 1 or 2 get -1. So here for the E5 from V3, so V3 will get 1 and 2 V4 V4 will get -1 and this is 0. E6 from V4, so V4 will get 1 and 2 V5, V5 will get -1, other value is 0. E7 from V5, V5 will get 1, 2 V2, V2 will get -1 and every other value is 0. Then here E8, here E8 from V9, so V9 will get 1 and 2 V8, V8 will get -1 and other two values are 0. For the E9, it is from V8, so V8 get 1 and V7 get -1, other two values are 0. And for E10, from V6, V6 will get 1 and V7 will get -1, others two values are 0. Okay. And after that, place the all other values with the 0 and it will be your matrix, incident matrix for the disconnected directed graph. Just fill these values with 0. And if it is found to be laborious, then you can also just place the 0 matrix here and with the dimension. That means you can replace this form, this total box form, by one big 0 matrix and with 1 2 3 4 total 5 number of rows and 3 number of columns, and this matrix as total 1 2 3 4 number of 0 matrix of 4 into total 7 number of edges. You can also replace it here, that this is 0 matrix, null matrix of 5 cross 3 and this is null matrix of 4 cross 7. Okay, so this is for the incident matrix. So for the incidence matrix also similarly you can draw the graph from the given incidence matrix. That means suppose the figure is given, the matrix is given and you have to find the incidence matrix, so you can also do that. So just take also one of this type of problem. So draw a graph. This is the problem, that means where you have to draw the matrix. Just take this problem, draw the graph corresponding and to the following incidence matrix. And this is the incident matrix, suppose 0 1 0 -1 0 and 1 -1 0 0 0 0 0 -1 0 1, this is 0 1 0 0 -1, this is 1 0, okay, take it as 1 -1 and then 0 0 0, then 0 0 1 -1 0 1 0 -1 0 0. So take it, this is the matrix and find the graph from it. So first of all we have to mark the vertices and the edges. So mark this as V1, V2, V3, V4 and V5, and then edges are E1, E2, E3, E4, E5, E6 and E7. Now we draw the edges one by one and also we give the direction. So first of all, here you can see the edge E1 is connected with V2 and V4. So just we start our graph with V2 and V4. So V2 and V4, here it is E2, it is E1 and the direction is towards V4. So arrow is in the direction of V4. So this is the first line. So from V2 to V4. After that we draw E2. So E2 is a line from V1 to V2. So just draw here one V1. So E2 is a line from V1 to V2. You can see the direction. Direction is towards V2. So from V1 to V2. Now E3 is from V3 to V5, so it is some different parameter, so we are taking it here. So it is V3 and it is V5. So E4 is E3 is from V3 from V5 to V3. Direction is towards V3. So from V5 to V3, this is the arrow direction. After that, E4. E4 is from V2 to V5. From V2 to V5, it is the direction E2. So from V2 to V5, that means this is V2 and this is V5. So just right, and it is from V2 to V5. Now E5 is from V1 to V2. So E5 is also same as the E2. You can see it. So it is also V1 to V2. So just okay, we forgot to mark all these variables. So U1 is actually from V2 to V4. After that E2 is V1 to V2. So this is E2. After that E3 is from V3 to V5. So it is E3, and I think it is E4 from V2 to V5, and also E5 is same. E5 is connecting line between V1 to V2 and from V1 to V2 again. So this would be a parallel lines like this. So from V1 to V2 parallel lines. After that E6 is between V3 and V4. E6 in between V3 and V4. So we can join these two line like this, and this E6 is from V3 to V4. So this is the direction from V3 to V4. Then E7 is from V1 to V3. E7 is from V1 to V3. So this is the direction. So that's the graph and from the incident matrix. Okay, one more thing, and this is not the intersecting point. Okay, these are not overlapping. So just it is a presentation. You can also connect these two line also in this way. It is also okay. But here we connect it. It looks like overlapping, but they are not overlapping actually. So this is the matrix. Now you can see, just you can verify these values. So the first, the E1 is connecting line between V2 and V3. E1 is connecting between the V2 and V4. Then E2 is connecting V1 and V2. And then this is, I think, E5. E5, and this line is E7, and this line is E6. So just put it. So first, E1 is connecting V2 and V4. E1 is connecting V2 and V4. After that, E2 is connecting V1 and V2. E3 is connecting V5 and V3. E3 is connecting V5 and V3. E4 is connecting V2 to V5. E4 V2 to V5. E5 is connecting V1 to V2. E5 V1 to V2. E6 connecting V3 to V4. E6 connecting V3 to V4, and E7 connecting V1 to V3. E7 connecting V1 to V3, and that's the graph G corresponding to the incidence matrix. This is the graph. So that's the way of calculating the incidence matrix for the directed graph. Okay. Now take one or two homework problem for the incidence matrix of the directed graph, and just take one or two homework problem. So one problem from calculating the matrix from the matrix to the graph, and one from the graph to the matrix. Okay. So just calculate the incidence matrix. One questions, calculate let the incidence matrix for the following digraph. Okay. Now this is the figure. Suppose, and this is V1, V2, V3, V4, V5, and the edges are E1, E2, E3, E4, E5, this is E5, okay, this is understood. It would be E5, it would be E6, it would be E7. So this is the number one problem. And number two, another problem is for the disconnected graph. So like the take one of the same problem where we start with this type of problem, one of this type of problem, and another with this type of problem where this is the first direction and another direction is that. Just take it as V1, V2, V3, V4, V5, V6, V7, and the direction are like this. This is the direction, and here this is E1, this is E2, E3, E4, E5, E6, and this is E7. So these are the lines, these are the edges, and these are the vertices. So I think every vertices and edges I have already marked. So if there is any problem or missing vertex and edges, just rectify that and place their one vertex or edges, whatever it is required. But I think there is no problem. So then calculate this is incident matrix from the graph. Now one most type of problem, and it is calculate the or from the graph from the graph uh, from the incidence matrix. And number one, the problem is that 0, -1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, -1, -1, 0, 0, 0, 0, 1, and this is 1, 0, 0, -1, 0, and 0. The number 2 is another, which is 0, -1, and 0, 1, 0, 0, 1, 0, -1, 0, 0, 1, 0, 0, 0, and there is 1, 1, 0, -1, 0. This is 0, 0, and here 1, -1, -1, 1, 0, 0, 0, 0, and it is 0, 0, 0. Okay. This is one. So just find the incidence matrix from these two. So these are two homework problems. So that is the end of the topic, and here basically we start with the definitions for the non-directed type of graph, then we state it for the connected graph, then for the disconnected graph, and also we do the same for the directed type of graph, first for the connected graph and then for the disconnected graph. And also we saw from the both direction, that means from the incidence matrix to the graph and also from the graph to the incidence matrix. So how to calculate all this, and that's the end of the lecture. So thank you all.